Hi children, welcome back to that is your channel Physics by Imagination. So in this class we are going to understand about that is fourth chapter moving charges and magnetism. Dear children, introduction part let us understand. So in 1820 it was first explained by that is Hans Christian Ørsted. Okay, it told that electric field and magnetic field are interlinked together. Imagine if it is a conductor. So then, as I told you, the rate of flow of electric charges, it is called electric current. Now, what is my point here? Around this, what is present? There is a attractive force. So that is nothing but magnetic field. So which was first explained by that is Ørsted, and hence this effect is called Ørsted effect. Means whenever a current carrying conductor produces magnetic field around that current, this is called Ørsted effect. Which effect, students? Ørsted effect. So now here, after that we understood the second point, magnetic force. So what is magnetic force? Now here, moving charges and magnetism. The children, as I told you, when the charge is at rest position, it is going to produce electric field. At motion, magnetic field. When the charges are going to be accelerated, it is going to produce electromagnetic radiation. That we have learned in the previous classes. Now, moving charges will produce magnetic field. So, that is due to magnetic force. Okay, how that force will affect? Suppose, if I take a magnetic field, it is a magnetic field. What is this? Magnetic field. And similarly, I'll take, so this is electric field. This is electric field. So now here, what is magnetic force means? As I told you, when the charges will be at motion, they experiences a magnetic force. Okay. Now, if I pass the charged particles along the direction of the magnetic field, very important for CET, when the charged particles are moving along the direction of the electric field, which gets a straight path. So that is straight path. If I move it, if magnetic field is perpendicular to the velocity of the charged particles, perpendicular, then it is going to get that is parabolic path. When I throw a ball, it is going to get parabolic path. That you studied in first PUC. So this is all about when the charged particles are moving along the direction of the magnetic field, straight. Similarly, along the direction of the electric field means straight. But here, in the magnetic field, that is circular path. In the electric field, parabolic path. Remember, charged particles are moving along the direction of the means like this. This is electric field. In this way, charged particles are going to be moved. So, it is going to have straight path. If it is moving perpendicular means, in the electric field, parabolic path. In the case of magnetic field, circular path. Now, if the charged particles are moving in the both electric field and magnetic field, then what is going to happen? So that is going to experiences both electric field as well as magnetic field. Okay, so that we'll understand in detail. So let us take the first point. When the charged particles is moved in the magnetic field. So here this is uniform magnetic field. This is uniform magnetic field. So here, if symbol is into, if symbol is like this, means the current are moving inside the circuit. If symbol is dot means the current is moving outside the circuit, outside the system. Now here it is a uniform magnetic field. Now charged particles are moving. As I told you, when the charged particles are moving along the direction of the magnetic field means that is moving straight direction, and perpendicular means it is going to get a circular path, then which explains a circular path, and charged particles will be moving like this. We can find a tangential force along these particles. Now here we'll get the expression for radius. The children, this is a uniform magnetic field and we have passed charged particles perpendicular direction. Okay, then what is going to happen? Here charges will experience, say, centripetal force which is coming towards the center, and also magnetic force. So here you can tell that is magnetic force is equal to centripetal force. So magnetic force means what? That is given by equation, very simple, BQV sin theta. So what is B? Magnetic field, Q charge, V velocity of the charged particles. Here it is moving perpendicular to each other. Then this is the expression for magnetic force. If theta is equal to 90 degree, what happens? It becomes BQV. Centripetal force mv square by r. You studied in first PUC. Then it becomes BQV is equal to mv square divided by r. This V cancelled, students. Then do cross multiplication. R is equal to mv divided by bq. This is the expression for radius of the electrons. I mean, you can find radius by using mass of the electron, velocity of the charged particles, magnetic field, and the charges. So after this, let us find an expression that, so we have got radius and we should get velocity and we should get time period. You just understand one by one. So this is, just note down, I'll write side here, it is R is equal to mv by bq. Let us get expression for velocity. Dear children, now particles are going to experience angular velocity, means the velocity of the charged particles from the axis of rotation, that is called angular velocity. We know that in first PUC, that is in rotational dynamics, V is equal to R into omega. This is velocity of the electron, angular velocity, this is linear velocity, this is radius. Now I want to get expression for angular velocity, means the velocity of the charged particles from the axis of rotation, that is called angular velocity. Now this omega is equal to V divided by R. Omega is equal to R is, what is the children? mv by bq. mv by bq. So VV cancelled, it becomes, it goes to numerator, bq by m. This is the expression for angular frequency. Must and should, you should remember children, they will be asking in the CT questions, formulas. After this, let us understand without wasting time, that is time period. So now we know that speed is equal to distance by time taken, and this is written as velocity, and d by t. Now distance covered by the particles is equal to circumference, and circumference of this is 2 pi r. It becomes 2 pi r divided by t. I want to guess this time period. So if I do cross multiplication, time is equal to, how to find time value? So this time is equal to 2 pi r divided by v. So we'll get the time expression as, you substitute, this is 2 pi v, I'll keep constant. R is equal to, take mv by bq, mv by bq. So this v and this v cancel the students. It becomes 2 pi m divided by bq. This is the important formula to find time of this electron. So next we go for, this is time period, time taken to complete one oscillation around the circular path. So let us go for frequency. So frequency and time period are inversely proportional to each other. So we can write directly, that is, note down, F is equal to 1 by T. So it becomes 1 by 2 pi m divided by BQ. It becomes BQ by 2 pi m. So this is the frequency of electrons. Please note down. So later on, we come to the point, that is, when the motion of the charged particles in the both electric field and magnetic field. The children, it's very easy. As I told you, when the charged particles are moving along the direction of the electric field and magnetic field, means they'll get straight path. In the electric field, moving perpendicular means this is the electric field. If it is moving perpendicular means what is going to happen? That is going to get parabolic path. If it is magnetic field, if the charged particles are moving perpendicular means that is going to get a circular path. Very, very important points. Now, so we'll get about motion of the charged particles in magnetic field as well as electric field. So then, the force experienced by the electric force of charge is given by QV. This is called equation 1. Okay, so this we got one. That is very basic equation. Electric field strength is equal to force per unit charge, and force is equal to E into Q, and that is force is equal to E into Q. And imagine this electric field and force are always opposite to each other, that we studied in the previous class. Now the magnetic force given by, that is BQV sin theta. BQV sin theta. So this is vector product of the two vectors. Vector product of the two vectors. Okay, that is A cross B is equal to magnitude of A, magnitude of B into sin theta. So this is magnetic force. If theta is equal to 90 degree, you will get Fm is equal to BQV sin theta. Now children, this expression, so now when the charged particles are moving in electric field as well as magnetic field, we are going to expression, that is the total force is equal to Fe plus Fm, and this force is called Lorentz force. Very important. What is Lorentz force? When the charged particles are moving inside the electric field as well as magnetic field, that is called Lorentz force. If in the case of magnetic force, if theta is equal to 90 degree, the force will be maximum. If theta is equal to 0 degree, sin 0, 0, the force will be minimum. So we'll get Fe is equal to QV into E plus, that is BQV. Now QQ cancelled. That is QQ common you take, then you will get Q into E plus BQ. The children, this is nothing but vector product of the two vectors. So we can notice, that is what you can write, BV is there here. So F is equal to Q into E plus B cross B. This is the expression for Lorentz force, where it is F is called Lorentz force, Q is charge, electric field, magnetic field, velocity of the charged particles. Please note down. So after this we are going to understand about, that is Biot-Savart's law. What is meant is Biot-Savart's law. So what is Biot-Savart's law? Very easy. The children, let us imagine it is a conductor. So as we know that according to Worsted effect, the current carrying conductor produces magnetic field. So all reason magnetic field is present. Now it's quite difficult to find the amount of magnetic field in the current carrying conductor. Hence I am going to take a small portion that is called current element, denoted by symbol dl. Means I am going to take very infinite symbol, means very, very small area, that is called current element, to find magnetic field. Now imagine this is a conductor. It's carrying a current I, and it is given by magnetic field at point P. So we'll understand Biot-Savart law. The children, as I told you, the current carrying conductor is going to produce magnetic field. Yes or no, students? Yes. Now, this amount of magnetic field, this law is going to be used to find amount of magnetic field in the current carrying conductor. Okay, it assumed by whom? Biot-Savart. Hence, it is called Biot-Savart's law. Very important. Now, this magnetic field is directly proportional to I. If current is more, then magnetic field will be more. If current is less, magnetic field will be less. And it is also directly proportional to dl. If area of element is more, so if area of element more means the number of charged particles are going to be gathered more and produce more amount of current. Hence we find around that there is a more amount of magnetic field. And also it is directly proportional to sine theta, means it should move perpendicular direction. And also it is inversely proportional to square of radius. If radius decreases, magnetic field increases. If radius increases, magnetic field decreases. So if I had these equations, I am going to get dB, and I am going to remove the proportionality. I will get a constant term. In physics, whenever you remove the proportionality symbol, we will get a constant term that is called proportionality constant, and this k is equal to mu naught by 4 pi. So have the equation IDL sine theta divided by r square. You can remember that is idli r square. Idli r square. You can remember like that. So this is the expression for Biot-Savart law. Okay. So this is all about this law. Imagine like this. And this law is not used to find whole amount of magnetic field in the current carrying conductor. So this is which imagined by Biot-Savart law. Okay. Now it is in vector form. They may ask in the CET. We know that vector form, unit vector is equal to vector by its magnitude. So it becomes, children, it is IDL sine theta. Now if I keep theta is equal to 90 degree, this expression becomes, so I am going to write here. We are going to discuss with only, that is Amperes law, next topic. So children, what is going to happen? That is going to become dB is equal to, that is k into I will take, that is dl cross r divided by r square into r. It becomes dB is equal to k into I, that is dl cross r unit vector divided by r cube. This is the vector form of Biot-Savart's law. Please note down. So later on, last topic, that is Amperes circuit law. The children, Amperes circuit law, it is very similar to Biot-Savart law. What did it tell? This amount of magnetic field is directly proportional to current and current element and the angle, and inversely proportional to square of distance between them. So Amperes circuit law. Amperes circuit law. So we are going to use vector algebra. That is, let us consider a conductor. So current is moving. You call I1, I2, I3. Now I2 is moving inside. This is moving outside. Okay. Current is moving inside, current is moving outside. Now this is moving inside. And this is moving outside. Moving inside, moving outside. Now very simple. This is inside, outside, again inside. So inside, outside, inside. Now what is telling here? The line integral of magnetic field. The children, this is line B dot dl means what, children? This is nothing but the amount of magnetic field. Amount of magnetic field. So it is very similar to Gauss law. The total electric flux passing through the conductor is directly proportional to 1 by epsilon naught times of the charge enclosed by the surface. Same thing here, this magnetic field is directly proportional to how much current it is going to move in the circuit. Means the line integral of the magnetic field is directly proportional to mu naught times of the current that is moving in the circuit. Here mu naught is equal to, that is 4 pi into 10 to the power of minus 7. Okay, so remember this one. Okay, so now here this is about Amperes circuit law. Very simple. If current is moving more means it is going to produce more magnetic field. If current is less means it is going to produce less magnetic field. Okay, so this is all about these topics, and next class we'll discuss remaining topics. So what did you understand? Magnetic force, expression for magnetic force, speed, radius, frequency of the charged particles. Later on, Biot-Savart law. Okay, and we come to the point Amperes circuit. And here, last but not least, velocity sector. Dear children, when charged particles are moving simultaneously, both the electric field and magnetic field. So now here, this is S1, now this is S2. Here electric field is present, here magnetic field is present. Now if I pass the charged particles moving to this, both electric field as well as magnetic field, then due to electric field, the charged particles are moving upwards, and due to magnetic field, the charged particles are moving downwards. So what is the meaning of velocity sector? The name itself it is telling that we are going to find the how the charged particles are going to get different velocities through in the presence of electric field and magnetic field. Now here magnetic force is equal to, that is electric force. Magnetic force is equal to electric force. We know that magnetic force means BQV, electric force means EQ, then QQ cancelled, then V is equal to E divided by B. Very important children, this expression many times they asked in the CT. V is equal to E by B, and remember this E and B are always perpendicular to each other, electric field and magnetic field. This is V, this is E, this is B. So they are always perpendicular to each other, means this electric field, velocity of the charged particles, and magnetic field are always perpendicular to each other. Okay, so this is called velocity sector. V is equal to E by V. Okay, this remember. Please note down. So remaining topics we'll discuss in the part 2 video. Thank you children for listening. If you like, please share and subscribe. Thank you.